So let's start. Metabolism and excretion of the drug and kinetic of elimination continues of yesterday's topic. So what you have learned yesterday, that is absorption and how it is getting digested, distribution. So today, then after the distribution, it will go into metabolism, that in the liver or in some other part, and then in the excretion. So what first is biotransformation. Previously, I've explained one slide that during when the drug bind to the protein or that bound to the plasma or the protein bound drug, biotransformation takes place. That is, what do you mean by biotransformation? It is the chemical alteration of the drug in the body. Suppose, let me take an example. If I'm consuming X amount of drug, X is a drug which I'm consuming, and inside the body, it is getting converted into Y. That conversion is known as biotransformation. That is, chemical alteration of the drug in the body is known as biotransformation. The metabolism of the drug usually convert lipid soluble and unionized compound. That is, lipid soluble means non-polar. Non-polar means which do not have any force. That is, both the charges are equal. That non-polar get converted into polar compound, that is water soluble, and unionized get converted into ionized compound. So next question is, why metabolism is essential? Have mentioned because protect the body from the ingested toxins. Means suppose you are consuming paracetamol. Consumption of the paracetamol, it means some metabolites are there which is harmful for our body. So to protect from that, they can cause toxicity in the body. So to protect from that, metabolism is required. Then what are the primary sites of metabolism? Mainly the primary sites of metabolism are, it is liver, mainly it is liver. Other than that is kidney or intestine or lungs and plasma. So बायोट्रांसफॉर्मेशन मीन्स उस चेंज जो होता है वो तीन चीज को लीड कर सकता है, मे लीड टू थ्री थिंग्स. दैट इज फॉर इनएक्टिवेशन. Inactivation is of the drug means if the drug is active, then it will get converted, means it will be inactive if biotransformation takes place after biotransformation. Second, active metabolite from the active drug. Drug is active, and from that we are deriving the active metabolite. Third, activation of the inactive drug. If the drug is inactive, then it converted to active. Then inactivation. What is inactivation? Inactivation means that, example means most have explained that most of the drug and the active metabolites are rendered inactive. Means if the drug is active, then it will get converted into inactive, or its metabolite also will get converted into inactive form. Example like paracetamol or lidocaine. Second, active metabolite from the active drug. Means if the drug is active, we are deriving if parent drug and then active metabolite, then its function will be more enhanced. So many drugs have been found to be partially converted to one or more active metabolite. That is effect. What I have said, both parent drug as well as the active metabolite will enhance its function. Like cephaloxime and its active metabolite is dicetyl cephaloxime, or codeine plus its active metabolite is morphine. Now third point is activation of inactive drug. Means if the drug is inactive, it's converted into active form. So when the drug is inactive and it gets converted into active form, these are known as its prodrug. So prodrug means we are deriving one or more active metabolites from the inactive drug. Okay? Like what I have written, few drugs are inactive such as need conversion in the body to one or more active metabolite known as prodrug. In the first year, we have learned the fibroblast. For example, in the dental lamina, fibroblast, these are in a state where they can change in any form. Same way, inactive drug also, if we compare that inactive drug is required, then it will convert into active metabolite. And these active metabolites are known as the prodrug. And prodrug has more advantage than the active drug. The prodrug may offer advantage over the active form in being more stable, high better bioavailability, or other desirable pharmacokinetic property or less side effect and toxicity. Have said that prodrug have more advantages than the active drug. That's why when active drug and the proactive drug get mixed, then its function enhanced. Like example, levodopa is the inactive form of the drug, and when it's converted into dopamine, its activity is enhanced. Moving to the next part, drugs mainly follow two types of metabolism, phase 1 or phase 2. Phase 1 is non-synthetic and phase 2 is synthetic. So in the diagram I have depicted something that a small descriptive diagram that you can understand easily. Suppose a drug, it first goes into phase 1 and then go to phase 2 and then excretion, or drug directly in the phase 1 direct to excretion, or the drug in the phase 2 or directly in excretion. Drug phase 2 followed by phase 1 then excretion, and thus drug in the unchanged form like IASH, that is isocyanides. Now what is phase 1? Phase 1 is also known as the non-synthetic phase or the functionalization reaction. Functionalization reaction means having the functional group, means functional group is present, that's why it's known as the functionalization. So functional group is generated or exposed, that is metabolite may be active or inactive. So it includes oxidation, reduction, hydrolysis, cyclization and decyclization. So let me explain one of the each term. First, oxidation. Oxidation means simple reaction where addition of oxygen or removal of hydrogen takes place. That's known as oxidation. Reduction, removal of oxygen or addition of oxygen, addition of hydrogen, sorry. Hydrolysis, that is breakdown of the compound by addition of the water, or common man among esters or amides. Next is cyclization. Cyclization, if we remember the chain reaction, cyclization means if it is in open chain, suppose hexane is in a ring and it can be in open form. So uh, when it's in a chain form, it's get converted into a ring structure, that's known as cyclization. And decyclization means it is in ring form, the compound get converted into break and form a long chain known as decyclization. These all reactions occur in the phase one, that is non-synthetic phase or the functionalization phase. You can ask in the Viva voice what are the other name of the phase one. Then we can say that it can be non-synthetic, we can say non-synthetic or functionalization reaction. Why? Because functional group is generated. So what is the result of the phase 1? The result of the phase 1 is metabolite may be active or inactive. This is the phase 1 reaction. Now phase 2. Phase 2 is also known as the conjugation or the synthetic phase. So here the result is metabolite is mostly inactive. If phase 1 metabolite is polar, it is excreted in urine or bile. However, many metabolites are lipophilic and undergo subsequent conjugation. What I have said earlier, non-polar and polar, which one get excreted out with absorption takes place? Did you remember? Lipid soluble drug, polar and non-polar, biological membrane. Same thing here also, that which are the non-polar compound will again get into conjugation and polar compound directly get into the metabolized. So when it's a non-polar compound, it's go under a phase known as the conjugation phase. So there are mainly 6 type of conjugation. First is glucuronide conjugation. So glucuronide conjugation means glucuronic acid is mainly involved. So what are the compounds? Like hydroxyl or carboxylic acid are easily conjugated with the glucuronic acid. This is known as a glucuronide conjugation. Second is acetylation. Acetylation means compound having amino We have seen uric acid. Titile coenzyme plays a main role. Third, methylation. Methylation means methyl bromate group cysteine. Like the amines and the phenols can be methylated. Means these are the compound which can be methylated. And what are the methyl donor? That they can be methionine or cysteine. Fourth is sulfate conjugation. Sulfate conjugation means sulfate is the main compound which will help in conjugation. So phenol compound and steroid are sulfated by sulfotransferase, that is known as SULT, salt. Salt means sulfo enzyme. Then is glycine conjugation. Glycine conjugation means silicate and other drug having carboxylic group are conjugated with glycine. Glycine is the main compound which helps in conjugation of silicate and the other drug and carboxylic group. Next is glutathione conjugation. Means it's a forming a mercaptine. Mercaptate is normally a minor pathway. Is the gas is present in the gas cylinder that are forming, and this step is a minor pathway. Not all the means all the drugs do not follow this glutathione conjugation. And last is ribonucleotide or nucleotide synthesis. Means for the activation of the purine and pyrimidine. This is the main thing. Activation of pyrimidine and chemotherapy. The cancer therapy chemotherapy we use the ribonucleotide or the nucleonucleotide synthesis when you get. Anything doubt up to this phase 1 and phase 2?
No,
Hello.
you may continue, Agni.
Actually, I'm not audible because I think
You may continue. You're not audible.
hello.
Yes,
I'm audible now.
you're audible, right? Yes, yes.
I'm audible now.
Yes, you're audible, Agni. You may continue.
Hello, I'm audible now. You all?
Yes, you're audible,
Then
Agni. You may continue.
first is where is microsomal enzymes are located. Microsomal enzymes are located on the smooth endoplasmic reticulum, that is mainly present in the liver or in the kidney or intestine and mucosa and lung. So what are the mainly enzymes? Enzymes are monooxygenase cytochrome P40 or phase. Then What are the types of reaction? Means microsomal enzymes are the enzymes which act on only few types of reaction, like oxidation in the phase 1, reduction in the phase 1, hydrolysis same phase 1, glucuronide conjugation, that is phase 2 reaction. Second, non-microsomal enzymes. One thing more, microsomal enzymes are inducible by the drug. Means we can activate microsomal enzymes by giving drug. Microsomal enzymes. Protein plasma. Are the enzymes, that is flavoprotein, oxidase, or esterase, or amidases, or conjugases. See, these microsomal enzymes and non-microsomal enzymes mainly we can get in that difference. What is the difference in microsomal and non-microsomal? Microsomal is not inducible by the drugs, so we cannot induce non-microsomal enzymes by giving some external drugs. Clear? Microsomal and non-microsomal. Then moving on the type of reaction. Type of they some of the oxidation and reduction may be hydrophilic reaction, and all conjugation means that the non-microsomal they act on all the oxidation reduction and all conjugation except glucuronide conjugation, because microsomal enzymes act on the glucuronide conjugation, so non-microsomal cannot act on it, and the rest all the phase 2 act the non-microsomal enzymes. Now next is a short topic that is known as Hofmann elimination. From here the elimination topics mainly getting started. So inactivation of the drug in a body fluid by spontaneous molecular rearrangement, means without agency of any enzyme. Suppose, let me take one example. Suppose I am going to a shop, then by in मीन्स हमको दुकान जाना, दुकान के लिए हमको बाइक चाहिए, मीन्स एंजाइम चाहिए जाने के लिए, तो मुझे बाइक नहीं मिल रहा, लेकिन मैं पैदल पैदल ही चल जा रहा दुकान, तो क्या हुआ, मेरा मॉलिक्यूलर जो रीअरेंजमेंट होता है वो कंटिन्यूसली होते जा रहा है, उसके कारण से क्या मेरा प्रोसेस तो हो जा रहा है, मैं दुकान तक पहुंच जा रहा हूँ. सेम वे हॉफमैन एलिमिनेशन आल्सो in the body by spontaneous rearrangement of the molecule without any agency of any enzymes, means either not microsomal also or non-microsomal also. That's known as Hofmann elimination. Hofmann elimination mainly that is atropine, that is a skeletal muscle relaxation undergo Hofmann elimination. This atropine is mainly a skeletal muscle relaxation undergo Hofmann elimination. Next, inhibition of the drug metabolism. How we can inhibit the drug metabolism? Means हम लोग ड्रग जो मेटाबॉलिज्म हो रहा है उसको स्टॉप करने के लिए क्या क्या करेंगे? Certain drug inhibit the activity of the drug metabolism enzymes known as enzyme inhibitor. Few enzyme inhibitor are there which inhibit the activity of drug metabolism. Enzyme inhibition is a rapid process as compared to enzyme conduction. And to enzyme induction. Enzyme induction means stimulation. We are giving stimulation to enzyme and then it's getting activated. So inhibition is rapid compared to induction. Example of rapid inhibition is allopurinol and its enzyme that is diltiazem, and ciprofloxacin that is MAO inhibitors. Next is enzyme induction. Enzyme induction is repeated administration of a certain drug increases synthesis of microsomal increases microsomal enzymes. Means what I have said, that if we are giving a certain drug continuously in our body, then it will stimulate the microsomal enzymes to get produced. These are known as enzyme induction. It is maybe acceptable drug because enzyme induction always accelerates the metabolism of the drug and can lead to the toxicity. Suppose, yes, one more thing is disadvantage is if more enzyme is stimulated, then it can lead to drug toxicity. Example in paracetamol in alcoholic. Paracetamol, what does it do in alcoholism? When you are consuming paracetamol, then enzyme gets stimulated, and continuous stimulation may lead to its toxicity. Next, moving to excretion. What do you mean by the term excretion? Is removal of a drug and its metabolite from the body, or in other term we can say, is a passage out of systematically absorbed drug. What are the drug we are consuming? It's move out from the body is known as excretion. What are the main channels? Main channels are only kidney. Other than kidney, it's like lung or bile or sweat or saliva, tear, milk, etc. First, one by one, I will complete each topics. First is kidney. First, kidney involves the three process. First is glomerular filtration. Second is tubular reabsorption, and third is tubular secretion. So, tubular reabsorption is a passive process, and tubular secretion is an active process. That's why I mentioned passive and active before them. So, glomerular filtration and active tubular secretion facilitate drug excretion, and reabsorption decreases drug excretion. Tubular reabsorption decreases drug excretion may be confusing because it's non-polar drug. So non-polar drug cannot be means it's get excreted, and polar drug is time taking. So when it's polar, it's again can reabsorb in the body for its some functional use, and then it's so that's why its drug excretion is decreasing. See, rate of renal excretion. From here, only some few type if in that need only few numericals have been asked from these topics, like rate of renal excretion equal to what? That rate of renal excretion equal to rate of filtration plus rate of secretion minus rate of absorption. वो means कितना filtrate हुआ प्लस कितना secrete हुआ माइनस कितना reabsorb हुआ, वो हम लोग का renal excretion कितना excrete हुआ. So explaining each term, what is glomerular filtration? Glomerular filtration is a drug with smaller molecular size and most rarely filtered. Means it's in the glomerular filtration. If we remember the diagram of the nephron, there are many afferent nerve and here glomerulus is present. From there, because it's a very minor pore, so if the drug is more smaller to that, then the drug will get more easily excreted out. So extent of filtration is directly proportional to the glomerular filtration rate and directly proportional to the fraction of the unbound drug. If the drug is unbound, then it will easily get excreted. As yesterday's topic was said, what is unbound drug and what is bound drug? Unbound, which are not bound to the plasma, and the bound drugs which are getting up means bounded with the plasma. Reabsorption. Tubular reabsorption is a passive, I have explained, because it is a passive diffusion, depends on the lipid solubility and ionization of the drug. See, lipid solubility explained yesterday's topic, what is lipid solubility and ionization. Ionization is most helpful because unionized drug cannot be excreted. Then strongly acidic and strongly basic drugs remain in ionized form and hence excreted. See, when treated in the from our body, and when it's get converted into unionized form, then it will get reabsorbed. We will see later what is unionized form. Next is tubular secretion. Tubular secretion is what I've said, it is an active process. That's why it is a carrier mediated active transport. Active secretion is unaffected by the change of pH of the urine and protein binding. Anything, it is pH is changing or it is ionized form are changing, it does not affect, but tubular secretion will take place because its energy is required and it is the carrier mediated active transport. Next is lungs. Lungs means alcohol or the volatile general anesthesia are excreted by the lungs. When you use volatile general anesthesia, it mainly get excreted through lungs. From feces that is are not completely absorbed from the GI tract are excreted in feces. Third is bile. Bile means bile means left. So bile means yesterday I've explained the enterohepatic cycle. What is enterohepatic cycle? First, it's getting the intestine, then it's moved to liver, and then bile, and then repeat its process. It's called enterohepatic cycle. Same way, bile is also helping some part of excretion. Last is the last topic. This is milk. Last is milk. Milk is that passive diffusion. It's mainly milk is not affecting the lactating mother, but this milk is get consumed by the sucking infant and adversely, and the infant get the drug. Therefore, we are speaking when in lactating mother, we will not which will affect the infant. That's why you are not giving because milk is one of the source of excretion of the drug. Now, what are the pharmacokinetics parameter? How we can measure the pharmacokinetics? So, pharmacokinetics are pharmacokinetics viability and its volume of distribution and plasma half-life and clearance. See, plasma half-life, yesterday you have seen bioavailability and its volume of distribution, how it is distributed. Now today we will see only two topics, that is plasma half-life and clearance. So what is plasma half-life? Suppose हम लोग कंज्यूम के 50, ठीक है, उसका कॉन्सेंट्रेशन उसको जब जब वो तो उसका 50% हो जाता है तो उसको बोलते हम लोग प्लाज्मा हाफ लाइफ. सपोज अ ड्रग इज 100 and in plasma concentration when it reaches 50, it's known as plasma, that is plasma half life. It's 50 concentration of. So like in the drug, it is a plasma concentration of the drug to decrease by 50 of its original volume. Now it's depend on the duration and frequency. In this diagram, if we see here, this point in 100 to 50 there is certain downfall. It is known as alpha phase, and from B to this lower part it is slightly changing gradually. So we'll explain what is alpha phase and what is beta phase. So 100 to 50 it is alpha, and from 50 to 0 it's getting in beta phase. Moving on to the next slide. This is alpha phase and beta phase. Initial rapidly declining phase is known as alpha phase. Yesterday we have seen what is distribution, and later beta phase is known as elimination. And yesterday what is elimination? This difference between distribution and elimination is distribution when drug we are giving drug, it get firstly diffused, that is known as distribution. Elimination when the drug withdrawal from there and move to some higher concentration like in the muscle. So from here T half equal to ln by 2 log 2 by k. So what is the value of log 2? We will 0.693. So k is the, from this topic mainly numerical have been asked. T half equals to log 2 by k, then k is the elimination rate. We can say fraction of the total amount of the drug in the body per unit time. Then we can denote by V. We will see what is clearance. Clearance by V. Then T half we can say from this first equation, that is log 2 multiply 0.693, that is 0.693 into multiply by V by clearance. V means volume of distribution and V means clearance. Next topic is kinetic of elimination. So what is kinetic of elimination? Mainly question what short note or we can give in 2 to elimination. Kinetic of elimination includes two parts: first order kinetic and second order kinetic. So what is clearance? Clearance means apparent volume of the distribution from which the drug is removed in बॉडी से ड्रग रहता है वो बॉडी से रिमूव हो जाता है पर कुछ टाइम के अंदर उसको बोलते हैं क्लियरेंस. सो वी कैन गिव क्लियरेंस इक्वल टू rate of elimination by plasma concentration of the drug. So what is rate of elimination and what is plasma concentration? We will see now. First order, what is first order kinetics? First order kinetics is that in a short form, that is first order kinetics directly from rate of elimination is directly proportional to the drug concentration. If we see this one, clearance clearance equal to rate of elimination by plasma concentration. Now first order, this rate of elimination is constant. Then obviously if this one will remove here, then plasma concentration will also be equal, is directly proportional to the drug concentration. So clearance remain constant here. Because clearance remains constant, therefore plasma concentration is equal to the drug of elimination. This rate of elimination is constant. When this rate of elimination is constant, then if clearance is increasing, then plasma concentration decreasing. That means it is inversely proportional to the concentration of the drug, this clearance. This is the main difference between first order and zero order. So this is the last topic of our topic. Pharmacokinetics is over. So shall I continue with pharmacodynamics or we will move to some other topic? Hello? Anything doubt here in today's topic? Hello? Hello? Okay. Then shall I end up the meeting here for today's? Then just suggest me what should I continue for the next. Okay. Chalo. Thank you for your patience listening.
Thank you.
Thank you.